Okay, hi everybody. Welcome to How to NFC. My name is Jeff Hamilton, and I'm an engineer on the Android team working on the NFC stack.
And my name is Nick Pelly. I'm also a software engineer on the Android team working on the NFC stack. I also want to introduce you to Ben Dodson, who is an intern on the Android team and will be helping with a number of the demos today.
So before we get started real quick, we'd just like to point out, hold on a second, we lost the slides here.
Should we switch to the other box?
Yeah. Okay. Okay, before we get started, we'd just like to point out real quick, we have some links for feedback for the presentation, if you'd like to give feedback on how we're doing up here. Also, we have some hashtags if you're going to be tweeting about the talk. You can see up here, IO 2011 and #Android. And we're going to take some questions at the end. We're going to take some live questions from the audience as well as some from Google Moderator. So if you have questions that come up during the talk, you can put them in online, or if you're watching the live stream, feel free to put some questions in there. And we'll get to those at the end of the talk. So we're going to talk today about, first, what is NFC? Second, we're going to talk about why use NFC and why this is relevant to you as developers to add to your applications. Third, we're going to talk briefly about how to NFC 101, just an intro to NFC on Android and what you can do as developers to add NFC support to your applications. And then fourth, we're going to go to how to NFC 201 and kind of deep dive in a little bit more on the technical details of the technology. So first, what is NFC? Just a quick show of hands, how many people in the audience are familiar with what NFC is?
Wow, that's a lot.
Yeah, that's quite a lot of you. So now we'd just like to do a quick show of hands. How many of the developers out there have added NFC support to their applications?
We're going to change this.
Quite a few hands were up for the first question, not so many for the second. So we're hoping at the end of this talk you'll have the information you need to add NFC support to your applications. So just real quick, what is NFC? It stands for Near Field Communications, and it's a wireless technology similar to Bluetooth or Wi-Fi, where you can transmit data wirelessly. Unlike Bluetooth or Wi-Fi, it has very short range. So the theoretical maximum is about 10 centimeters. On a smartphone, you're going to see closer to 1 to 4 centimeters typical range for interactions. NFC is also typically low speed, so you're going to get between, depending on your configurations, 106 to maybe 414 kilobits per second. That's kilobits, not kilobytes. And that kind of depends on your configuration as well as, these are theoretical maximum numbers, so you might see lower speeds than that. So, those two properties, don't really compare to Bluetooth or Wi-Fi, but what's really great about NFC is it's a low friction setup. So because it only works at short range, anytime you bring two devices that support NFC within that range, they're going to set up a connection and be ready to talk to each other. So there's no discovery like you have in Bluetooth. There's no pairing. You don't have to put in passwords or anything like that. And this is really, we think, a magical property of NFC that really makes it kind of a science fiction type of technology. Things just work. Additionally, NFC supports what is called passive targets. And so these are devices that do NFC, but they don't have batteries in them. So these are things like stickers or just random devices that aren't powered can support NFC. And it's a little tiny microcontroller there with an antenna, and it picks up the power from a secondary device, and it actually powers up the device from another one. So you can interact with things in the world, and they don't need power. And that's a really interesting property of NFC that doesn't exist in any other technology. And we think it really enables interesting applications for the technology and great things that people can do with it. Okay, off to Nick.
So Jeff's talked a little bit about the basic properties of NFC. And hopefully some of you in the audience have some ideas of how you can use these properties to build awesome applications. Today, we want to make the case to you of why NFC is going to be so compelling to users. Why should you care about NFC? Well, We like to think of it as bridging the physical and the virtual worlds. Now, this is a kind of cheesy saying, but this is really true. With NFC and its low proximity, you can bring two devices next to each other, and it'll trigger a virtual reaction. Physical actions, virtual reactions. This is something that we haven't seen from any other wireless technology. Bluetooth, Wi-Fi, you don't have that easy connection set up. This is new to NFC, and we think users are going to love it. Let us show some demonstrations. So first, basic tag read. You may already be familiar with this, but we're going to show it anyway. Everyone has a Google I/O badge, and inside it, you've got your NFC sticker. I've got one of them here right now. So you may have already tried this with your Nexus S. If not, let me show you how easy it is to read content off of this tag. You take your Nexus S, if I get the right phone, at the home screen, and just touch it to the tag. And there you go. I've read Jeff's contact details. That's a V card. So, these are stickers. You can start thinking about where you might want to place these stickers. A useful one for Jeff would probably be on his front. So we can now tap Jeff and read his contact details.
Come see me after the talk.
So these stickers don't need any power. They're inexpensive. They're becoming cheaper. You can think of them a little like QR codes. You can embed basic data onto them. Let's now go to a few more demonstrations of the kind of content you can put on an NFC tag. We're going to switch to the demo board, where we have a number of tags embedded into the board so that we can quickly tap different areas and show you the NFC content in the tags. But these tags could just as easily be a sticker or a card or any other form factor. So Ben's going to just tag a few of these and show how easy it is to read content. The first one had a URL, android.com. The Wi-Fi is a little slow, but here we go, it's coming up. The next one has another V card, and then the next one should have some text. So hopefully you're getting the idea. We can put URLs, text, contact, in fact, any MIME data type into a tag. And most importantly, when you touch the phone to the tag, it doesn't matter where you are. It doesn't matter that you don't have any application running. You can be at the home screen, and it will take you to the right application to handle that content. That's really powerful. QR codes don't do that. Let's do a direct comparison, actually, of NFC versus QR codes. This is a little bit unfair, but let's just do it to see the difference in speed. So Jeff is going to try and read a Google Places location embedded in a tag by scanning it with NFC, while Ben is going to try and read it from the QR code. So 3, 2, 1, go. And the NFC tag's already done. It's a little bit unfair to QR. You have to, fire up the application and focus the camera. Good luck if you're in low light conditions. So the key point here, NFC is just really fast. It's low friction. We think users are going to love it. And you can see the sequence with QRs. So let's now go to an application that we put together in just a few days. We have APIs for NFC read, write, and peer-to-peer that are already a part of the Gingerbread platform today. So we've used these APIs to put together an application called Sticky Notes. It's just a very simple application to show you how easy it is to use. Ben is going to tag this phone to some text, and it's going to automatically launch the Sticky Notes application. That's it. It's read the content. We can now show you that it can actually write content to these tags as well. This is something we haven't mentioned yet. These tags are reprogrammable. They have their own microprocessor. It's not like a QR code. You can actually program these things once they're already deployed. So can we get like a word or a phrase that you want to put into a tag here? We can demonstrate it live. Chicken? Okay.
Chicken it is.
That was really quick. We got a lively audience. Okay, Ben's programmed it into the tag to prove we're not faking it. Jeff is going to use a different phone to read it back out. and note it's going to launch the sticky notes application again. That's it. It's just so easy. So now the third mode.
There we go.
Thank you. The third that's really interesting is peer-to-peer. Yep, you can read and write to these passive stickers. And yeah, there are plenty of other peer-to-peer protocols, Bluetooth, Wi-Fi. What makes NFC so interesting is that it's triggered by the proximity. So you don't need to go fumbling around in any UI. You just put the two phones together. So what we have is the two phones, both in the sticky notes application, both with different text contents. With a Nexus S, the antennas are on the back of the phone, so you place them back to back, and they've exchanged content. That's it. You don't need to go fumbling around in any menus. We're going to show some more peer-to-peer demos, and we're going to do it using the demo board. There's the outline of two Nexus S phones on here. They've actually got antennas hardwired behind them so that we can show you the front of both phones as we do peer-to-peer. But if you're trying this at home, you're going to want to put the phones back to back. So we hope that you're beginning to see some of the possibilities of this technology. What we wanted to do was just throw together some demos of some more sort of sci-fi, like, what can this proximity-triggered interaction enable? So we wanted to create a wormhole. We programmed two tags to be the endpoints of this wormhole. You can imagine that one tag is in Australia, one tag is in San Francisco, and when you place one phone on the first tag, it begins the wormhole. And on this other tag, we've taken a risk with these demos. We've got NFC, Bluetooth, and Wi-Fi at a conference, so the Wi-Fi is a bit slow. But what's going to happen in a decent Wi-Fi connection is you're going to have a video chat complete, and you can be talking to someone on the other side of the world just through touching the phones to a tag.
Try one more time. Some people claim wormholes don't exist, so.
I guess Einstein was right. All right, let's go to another demo. So we worked with Half Brick Studios, and in just a few days, we took the Fruit Ninja application and added NFC and Bluetooth to make it head-to-head multiplayer. Now, head-to-head multiplayer games over Bluetooth is not really new, but what is new is using NFC to initiate the connection. So we have one phone at the Fruit Ninja menu screen. The other phone can be anywhere. It's just at the home screen right now. Put them together and see what happens. That's it, straight into a game. Isn't that awesome? It looks like our intern's been practicing this one.
He's pretty good.
So I want to be really clear. Everything we've shown you is possible with Gingerbread APIs. This can all be done today. We're going to make it easier for developers with some additional APIs in Ice Cream, but the functionality is already there. Let's talk a little bit more about Ice Cream Sandwich. I hope you're already convinced that NFC is an interesting technology, and we really hope that we've got your imagination going with the kinds of activities that you can build out of this physical interaction. We think it's really interesting too, and we think this is just the tip of the iceberg. Here's some ideas that we're going to put into the Ice Cream Sandwich release. We want to really focus on these zero-click interactions. We keep coming back to the one key feature. You can just put two phones together without any UI, without having to launch any application and share content. So we're going to bring zero-click sharing into the platform for Ice Cream Sandwich. Let's show some demonstrations. Ben is viewing a contact. You put the other phone next to it, and immediately it just shares that contact. This is how easy it should be. It's just sharing the on-screen contact with the other phone. Let's go to a web page. Ben's going to load a web page. Android.com, put it against another phone, and as you can guess, it just loads the web page. We want to build this into as many system apps as we can, and we want to make the APIs for this easily available to application developers for use with your applications. So there's one more demo that we want to show. We don't have NFC in a tablet yet, but we have hacked up this tablet with a NFC evaluation board to show you, what can be possible when we have a broader range of devices available with NFC. Let's say you're watching YouTube on a Nexus S. It's got a great screen, but the tablet is so much better. Here's what we think should happen when you touch your YouTube video to the tablet. And you notice it resumes playback right where the other one left off.
If only I could dance that well.
So we hope we've got you excited. There's one more demo that we think the application developers in the audience are going to be particularly excited about. And that is application sharing. So let's say that one phone is running Fruit Ninja. The other phone doesn't have Fruit Ninja installed. What should happen when you put those two phones together? Well, let's demonstrate.
Right, let's see.
There you go. Take you to the market to download it. This is going to encourage viral app sharing. If you and your friend, you want to share an app to a friend, you don't have to go search for it in the market. You can just touch your phone to theirs, and they can download it. I'll now pass back to Jeff for how to NFC.
Thanks, Nick. Those were some great demos. So we've seen a little bit about what you can do with NFC, what the technology is like, and hopefully you all are starting to think about what kinds of things you can do in your applications using NFC. So let's talk a bit about how you would do that. So first we're going to talk quickly about how to read data over NFC. Then we're going to talk how to write data over NFC, and then we'll get into some more advanced topics at the end. The first thing to know when reading data from NFC is that there's a data structure called NDEF. This stands for NFC Data Exchange Format, and it is the data container format to use for NFC. The reason that there needs to be a standardized data container format here is that on the passive tags, there's a lot of different types of technology that exist, and they all have a lot of different properties, different ways they store data on them, and things like that. And so the standard NDEF here is designed to be able to work across all of these different types of technologies. And it's just a way that you can interact with NFC devices and be guaranteed that you're going to have a common data structure across these devices from many different vendors. So the general structure of NDEF is first you have a message, and the message encapsulates within it one or more NDEF records. And the message is just an encapsulation of records. The records that you have in there, each record has a high-level type, and then there's optionally a second-level type that's scoped within the first-level type. There's an optional ID within the record, and then there's an optional payload as well. For more information about NDEF messages and NDEF records, so the NDEF message and NDEF record classes in the SDK, there's a bunch of documentation there with the gory details.
NDEF was the container format we used for each of those demos.
Yeah. So the first thing to know about NDEF when reading it on the phone is how it's going to be dispatched to your application. So by design, the NFC data is dispatched to only one activity on the phone. And we think this is actually a very important aspect of the way we design the system, because when users are interacting with things with NFC, they really are looking for instant gratification for the way that they're interacting with things around them in space. And so what we really wanted to do is we wanted to launch directly into the application that handles the data that they're interacting with. And we really think that, for the best experience for the user, going directly to the application is very important so that they can interact with things around them. So let's talk a bit about how you get into your activity when data is read over NDEF. So what we do is we take the first NDEF record in the NDEF message, and we look at its type. And we build an intent from that type. So this slide shows some examples of how we're going to take an NDEF record and convert it into an intent. And we show that on the right-hand side with some snippets from an Android manifest file. And this is how you would capture NDEF data coming into the phone from your activity. So the first two examples show how we're handle just raw text coming in. And so the sticky notes example that we showed earlier handles text plain MIME type. And it just deals with general text. So there are two ways you can get general text. There's a top-level type well-known with a secondary type of text, and the payload is just text. The second one is you can have MIME data in an NDEF record. So if you have a MIME data, and the secondary type is text plain, the payload, again, would be just text. And what we do is we take the MIME type there, text plain, and we put that on the MIME type field for the intent that we start when the data comes in. And that lets applications filter on the different types of data that they're interested in. So taking that a step further, the third example here is using the application/vnd.example, and this is the generally accepted format of doing vendor-specific MIME codes, or MIME types. And so this is something that we think would be great for developers. If you have a data structure that you want to put in a sticker or that you want to transfer over peer-to-peer, you can just create your own custom MIME type using vnd dot and then your domain name, and put your payload in there. What we do is we take that MIME type, we put it into the intent, and from your Android manifest, you can just specify that you want that MIME type coming in from NDEF, and then your application will get launched directly to handle your data structures. And the last example, you can do basically the same thing using a URI. So there are 3 different ways you can store URIs in NDEF. If we find one of those 3 ways, we pull the URI out, and we set that as the data field on the intent. And you can use the existing standard Android manifest matching mechanisms for saying which URIs you're interested in. And you can be as specific or generic as you want when setting up that match in the system.
You can think of NDEF types as like a superset of MIME and URL types, and Android does the work for you in mapping those to MIME or URL types for intent filters.
OK, so now we talked a little bit about how we build that intent. Let's look at some code snippets for how applications would actually handle that. The first one we have here is the Android manifest from the sticky notes example that we showed earlier. And it's just an extra intent filter that has the action NDEF discovered on there. And this one, for the sticky notes, was looking for text. So it sets the MIME type to text plain. Here you would just put in, in this intent filter, you'd put in some kind of filter there for whatever data type you have that your application is dealing with over NFC. The second code snippet we have here is just the activity and how it would handle it when it receives that intent. There's basically just an extra on the intent called extra NDEF messages, and that's an array of NDEF messages. Typically, there's only one NDEF message that comes in over the payload. But it is an array because it is possible in some cases to have multiple NDEF messages. So typically, you just look at the first NDEF message in that array, get the first NDEF record in there, and off you go.
This code snippet is straight from the sticky notes application that we demonstrated, and the full code is available. It's linked at the end of the presentation.
So let's talk real quick about best practices when dealing with NFC and NDEF data. I think this is very important that you always want to use precise intent filters. You don't want to just say, I capture URIs that all have HTTP as their scheme. Because if multiple applications are doing that, you're going to get something like we have in the slides here, where you have an activity chooser dialog, and the user is really not going to have that instant gratification that we think is really the hallmark of NFC and what makes the technology really exciting for users. And it's not going to be a great experience for them. So we highly suggest that you structure your data in ways that you can create precise intent filters with custom MIME types or with URIs to domains that you control so that you're not going to be stepping on each other's toes, and it will be the best user experience for all the users out there. I think another thing worth mentioning as well is, we talked earlier about how NFC is kind of slow on the data transfer rate. So we'd also recommend that you keep your data structures on the smaller side. Typically 1 kilobyte or less is a good recommendation.
Please, no XML over NFC.
Excuse me. OK, so we talked about reading NDEF. Now let's talk about where you can read it from. So you can read it from passive tags, as we showed in the demos earlier. There are a bunch of different types of passive tags. So the NFC Forum has gone out there and they specified 4 standardized types of passive tags. They're called type 1 through 4. We have up here some examples of products that implement these specifications. These are the most common implementations of these specifications that you'd find out there, although they're not the only implementations that exist. There's the Topaz Type 1, MyFair Ultralight Type 2, Sony Felica Type 3, and MyFair Desfire Type 4. Outside of the NFC Forum defined types, there's also some proprietary NFC tags. MyFair Classic is the best example of that. There's tons of MyFair Classics out there in the world today. And they support NDEF as well. So because they're not completely standardized, support for those is optional in Android. Not all devices are necessarily going to be able to read these tags. The Nexus S can read them. But if you're putting a deployment out there in the world, we highly suggest you go with one of the standard type 1 through 4 tags, because then you'll be guaranteed that all devices will be able to read them, and you won't run into any problems with people who have devices that can't read the type of tag that you've deployed. And last but not least, you can read NDEF peer-to-peer. And this is from one Android phone to another. And we think that's a very exciting way to read it as well. So we talked earlier about NFC stickers. I think you all have probably seen these in your badge sheets. The stickers that we've given you are type 4 tags. They can hold up to 2 kilobytes of data in them. If you read the sticker in there with the Nexus S, it will take you to a web page that has a link to documentation about NFC, some sample code from the Sticky Notes application, as well as a link to the NXP Tag Writer application from our friends at NXP. And you can download that from the marketplace, and you can use it to rewrite the tag and play with it and put whatever data you want in there. One thing to note, these tags are rewritable, so you can put whatever data structures you want in there. You can play around with them, use them to develop applications. But beware that you can't make them read-only. So if you are going to put them up, stick them around somewhere, beware that someone might come around and rewrite them on you.
Yeah,
and who knows what they'll put in there. Keep Nick away from your tags. OK, so let's talk a bit about writing in more detail. As we said, NDEF tags can be writable. It's also possible to configure the tags to be read-only from the factory when you purchase them. The type 1 and 2 tags, it's possible to make read-only at any time. If you have a read-writable tag, you can mark it read-only, and that will be honored in the tag. For types 3 and 4, they have to be configured as read-only from the factory. So if you get a rewritable tag like the ones we've given you guys today, you can't mark that tag read-only later on. So that's something to be aware of if you're looking to deploy tags out in the field. So when you go to write tags programmatically on Android, you have to do that when the tag is in the field of the phone. So that's when the tag is touching the phone pretty much. And we have a code snippet here, again, from our Sticky Notes sample code. You can go download the sample code on the web page. Basically, you just create up an NDEF record that has the text that you want to write into it, encapsulate that in an NDEF message, and then get a reference to the tag object that you want to write to, and the NDEF technology you're going to use to write, and then just call write NDEF message, and it goes out over to the tag, and you're good to go. So writing peer-to-peer is a little different. The way we set it up on Android is only the foreground activity can register a payload to push over a peer-to-peer link. So the application needs to register that payload in advance. It's something that we think is really important in the way the APIs are set up, excuse me, because we want to make sure that the user is aware of which activity is using the NFC radio.
Yeah, I think it's a common theme of our APIs, actually. We always want to encourage the foreground activity to be the one using NFC. It's for instant gratification, and so the user knows exactly which application is using the NFC link.
Yeah, so your application on Resume would just call the NFC adapter or API enable foreground NDEF push. And you hand off an NDEF message. And so what happens then is the system will take that NDEF message, and when a peer-to-peer link is established, it will hand that NDEF message over to the other phone on the end of the peer-to-peer link, and it will dispatch that NDEF message as if it had been read from a passive tag.
You can use the same code on the receiving side for peer-to-peer as you used for reading a passive tag. It looks the same. You just receive an NDEF payload.
So this is a really nice API. We think it makes it very easy to add peer-to-peer support for NFC in your applications. You just need to call enable foreground NDEF push from your on-resume and hand off the content. One thing that we really thought would be pretty handy in the API, and unfortunately we didn't get it into Gingerbread, we will add this in Ice Cream Sandwich, is you can add a callback system, or you can register a callback. So when the peer-to-peer link is brought up, there will be a callback made to your application, and you can return an NDEF message at that time that's relevant to the state of your application when the link is established. And so that's something you saw earlier with the YouTube example. The YouTube application on the phone is using this Ice Cream Sandwich API, and it's responding with not only a link to the video that is playing back, but also the timestamp of where it is in that video, so that the other side can start playback at the same point.
Okay, so Jeff's covered the basics of how to NFC, and we've really focused on NDEF tag read, NDEF tag write, and NDEF peer-to-peer. There's a theme here. We're talking about NDEF. But are all NFC tags NDEF? Well, they're not. So we're going to go into detail about the NFC ecosystem on a broader level. Don't worry, we're not going to go too deep. There's a lot to talk about here, but we'll just make you aware of some of the things that you should know. So NFC as a technology has actually been around for over 15 years, but NDEF is a fairly new standardization. And over that 15 years, companies have invested heavily into NFC for transit, for credit cards, for passports, for physical access cards. There's over 5 billion of these already out there that your Nexus S or other Android NFC phone can talk to already. Now, it's probably a good time to bring up RFID. We haven't mentioned it yet. RFID is a different technology to NFC, and it really bugs me because I keep reading articles where they replace NFC with RFID. They're a different set of technologies. RFID is typically working at a range of meters. NFC is exclusively a centimeter range technology. This is really important. This means that you're going to get that proximity-triggered interaction, physical reactions, virtual reactions. And it means that you don't have to worry so much about many devices being in the field or privacy and security. Anyway, so when we quote the 5 billion number, that's 5 billion NFC tags. So this is a crazy diagram of all the different NFC technologies that have, well, it's actually a subset of the technologies that have been out there for the last 15 years. When we rehearsed this, I can talk for half an hour about all these technologies, but my product manager was like, no, let's just spend 30 seconds. So all I want to do is let you guys know there are a bunch of different technologies that are all sort of fall under the NFC ecosystem. And all those tags that are deployed that are non-NDEF are going to use one of these technologies. Now, the good news for you guys today is that we have built APIs to the majority of these technologies so that you can read and write with all of these legacy tags that are already out there today. So I won't go into the detail, but if you want to look into using these classes, the package is android.nfc.technology. We've got a set of classes like ISODEP, NFC A, NFC B, NFC F. If you know NFC well, you might have heard of some of these before. And we have all the low-level commands you need, transceive, authenticate, read, write, to use all of these technologies from your Android applications. So I will mention that when I say technology, I kind of mean protocol. Any given tag can have an RF-level protocol and then one or more other protocols building on top. So don't be surprised when you see multiple technologies enumerate on a single tag. Now, we talked about dispatching to your application with NDEF. We use the NDEF discovered intent. It's a start activity intent so that we always are bringing an application to the foreground. Well, it's the same with non-NDEF tags. We use the tech discovered intent. It's a start activity intent. We're trying to bring your application to the foreground so the user gets instant gratification. The content that you filter on is no longer the NDEF type because we don't know the type. It's some unknown tag with different technologies on it. So instead, you filter on the technologies you want to use. So, for example, if you're writing an application to read information off of a transit card, you might specify that you're looking for cards with NFC A and ISO-DEP because you know that all the transit cards you care about have those technologies.
I think it's worth noting here as well that the NDEF dispatch phase, it happens before the technology phase. So if you're writing an application and you're using NDEF, and you're using the intent filters like we described earlier for NDEF data, that's going to happen before the technology discovered happens. So basically, we call start activity if we get any results back for activities that handle that NDEF data structure. We just launch directly into them. If there are no activities installed in the system that handle that NDEF data structure, then we'll go on and we'll try to dispatch and call start activity on action tech discovered with the technologies that are present on the tag that's in the field. So if you're using NDEF, that takes precedent over the technology level. And we think that's kind of important because NDEF allows much more precise filtering to applications. And that's a great way to get directly into your application and for a better user experience.
Now, please use NDEF if you can. But if you can't because you're using legacy tags, then look at tech discovered. While we're talking about dispatching tags to your applications, there's one other important dispatch mechanism we want to mention. We have a API function, enable foreground dispatch. When your activity is already in the foreground, you can call this to tell the Android operating system that you want to receive all further tags into your application and not some other application. This is really important because otherwise, if you're trying to write to a tag from your application and then you scan a tag, you can make sure that you're not going to launch to some other third-party application. It's going to stay in your application, and you can receive all the new tag updates. So this is a good tip to look at enable foreground dispatch. OK, I just talked a whole bunch about passive tags, reading and writing. Let's talk a little bit deeper about peer-to-peer. The key feature of NFC for peer-to-peer is that it's low friction. There's no discovery, there's no pairing. You just touch the phones together, and it'll launch the application. However, it's got a low range. It's only going to work when they're sort of 1 to 4 centimeters away. That's not great for playing a multiplayer game, and the data rate is really slow. So like with the Fruit Ninja demo, we really recommend to switch to a higher bandwidth connection like Bluetooth, or you could equally well use Wi-Fi, or even go through the cloud for your heavy lifting in the application. Bluetooth and NFC, they go together so well. We really recommend you look at this.
It's wireless nirvana.
NFC to initiate the connection, and then Bluetooth for the heavy lifting. Please don't do socket-style communication with NFC. It just doesn't work so well. OK, we're getting towards the end. We just want to recap on the key points that we've presented to you today. Number one, I think we've said it a few times now, but just to hammer it home, NFC is quick connection setup. That's what it's about. So please think about how you can use this in your applications and the kinds of experiences your users are going to get out of this. Number two, you can work with passive devices, stickers, tags. You can take these stickers and just place them around the environment on people and just see what happens. NDEF dispatch. Use precise intent filters and prefer NDEF over the legacy technologies. Number four is foreground interaction. The APIs are designed to work in the foreground. So we really don't want to encourage applications to be using the NFC connection in the background. And lastly, for socket-style communication, please use Bluetooth or some other higher range connection. We're about to go to Q&A, but I want to just cover a few topics that we know are going to come up first. Privacy. So, when we work with NFC, we often hear people talking about privacy, and it's a really important topic to discover because we do care about user privacy. I don't want people reading my contact information out of my phone without me letting them. So I want to touch on a few points. First of all, NFC is not RFID. It does not work at a range of meters. This is a centimeter technology. You have to be really close to the phone in order to communicate with the NFC antenna. It's a very low-powered antenna. Second point is, the NFC is off when the screen is off. So, as I like to call it, there's no butt sniffing. You can't go and scan someone while the phone's in their back pocket and the screen's off.
That's a good thing. You don't want Nick doing that to you.
I thought you took that out of the slides. And lastly, third-party applications, they must be in the foreground. We really think this is the right usage model. It's instant gratification, and it means that you know which applications are using the NFC link, and you know if they're misbehaving. Okay, second hot topic is security. It's related to privacy, and some of the important points are similar. NFC is by design low range and low power. So if someone was to try and intercept or eavesdrop on a communication, they're going to need to be very close in order to see what's going on. Now, that said, there is no link-level encryption built into the standard NFC protocols. So if you care deeply about the payload, if the payload is a financial instrument or something else that you need to keep secure, then you should encrypt it. Or you should look at some of the more advanced NFC technologies that do have encryption built into the lower level. But by default, don't assume that the link level is encrypted. Lastly, card emulation. This is the most popular question on Android developers' Google groups. So we talked a lot about reader-writer mode and peer-to-peer. There's a third major mode of NFC, which is card emulation. This is when the Nexus S is pretending to be a passive tag that you can put in the field of a reader-writer. So if you wanted to pretend to be a transit card or pretend to be a credit card. So in Gingerbread, we have no API support for card emulation. And it's not that we forgot. We thought very hard about it. But there's some simple reasons. I showed you that diagram earlier of all those different technologies. Well, if you're going to do card emulation, the hardware has to pick one of those technologies to emulate. You can't typically emulate all of them at the same time, and the hardware out there today doesn't actually support all of these at the same time anyway. So if we were to build these APIs, the applications are going to have a really inconsistent experience as they're deployed to different Android devices. Some will support NFC-A, some will support NFC-B. We don't think this is really going to be a great story for third-party developers right now. And secondly, when you're doing card emulation, you're emulating a passive target that is going to have 1 kilobyte, 2 kilobytes of memory. You're going to have to then decide which application has the right to manage this limited resource. So we did not put card emulation APIs in Gingerbread because we want to make sure that we have a compelling user story before we do that. And we really think that peer-to-peer is the way to go for future NFC uses. Peer-to-peer and NDEF, because with NDEF you can filter on content, and with peer-to-peer it's a newer technology. It doesn't have to assume that one side is passive. So that's it for the main part of the presentation. We encourage you to go to nfc.android.com. We have links to the sample code for sticky notes, links to the developer APIs, and you can give us feedback on how we went today at the feedback link. You can tweet about this with the hashtags, and we're going to now take questions from the audience live, and also you can post questions online at the last link. Thank you.
Get this up to the questions.
There we go. Is the one on there? Okay, can we go to the first question live in the brown shirt?
So, what can you tell us about your plans for other devices that will support NFC in the near future? Other than the Nexus S?
Well, I think it's up to the OEMs. I think they are going to want to. They would love to see more applications in the market. So it's kind of up to you guys to write some really great applications out there that really, make the OEMs see the use cases for NFC. Yeah, and you know, we do know personally of dozens of phones in the pipeline for 2011 that are going to have NFC. So don't worry, they will come as well.
Thank you.
Okay, can we take a question from the back mic, please?
Good. Well.
Yeah, that's you.
So yeah, are there intents then to update all of these standard apps, contacts, Gmail, the browser, to have a standard NDEF payload that they're just showing all the time?
Yeah, so that's something that we showed off in the ice cream sandwich preview. So
Right.
that's something we're going to look at adding in the ice cream sandwich platform. In the demos that we showed, like from contacts, it's exporting a standard V card. So it's a MIME type with just V card. So that's a pretty big standard there. URIs come through just as a URI. There's an NDEF record specification for how to store URIs. So those come through just like that. So NDEF as a format covers pretty much all the data structures that we would export. And for things like contacts, we just go with the standards like vCard.
All right, so ice cream sandwich is when we'd start to see that just show up in the standard apps.
Yeah, in the platform. So in your applications today, you as developers can add support for this stuff today on Gingerbread.
Right. Okay.
Maybe we'll take a question from the Google moderator. Are we going to have a way of using NFC in the emulator? And that's something that we get asked a lot. And I think, for right now, we really encourage you to buy Nexus S and use it with real hardware. But we are working on it for the emulator, and hopefully soon.
Yeah, I think that the problem with the emulator is as we saw with that diagram, there's so many different technologies that exist in the realm of NFC. It's very difficult to support all of those simultaneously in the emulator. So that's something we're working on.
Question from the front?
So the lack of card emulation support, does that mean you can't do mobile payments with NFC as it's implemented in Gingerbread?
It means that you can't do mobile payments with the APIs available in Gingerbread.
And are you planning to add that in for ice cream sandwich?
It's something that we're not going to rule out.
What's the sort of missing pieces there that you're looking for to make that what you call a compelling environment to enable that?
Is it at an API level, you mean?
Yeah, I think if I understood you were saying it's just not a compelling
The
proposition right now. What are the missing pieces to make it compelling?
The problem is that the hardware out there today, if you buy an NFC controller, it typically is only going to be able to emulate one of those RF level technologies. So as an application developer, you don't know when it's getting deployed to a phone, which one is on the phone. So I guess until we see the industry standardize around maybe one RF level technology, or until we see NFC controllers able to support multiple of those, I guess we're actually hoping that everyone will just move to peer-to-peer or NDEF exchange, because that removes this problem entirely.
Looking for a standard in the frequency supported.
In the modulation of they all do 13.56 megahertz, but they have different modulation schemes.
We'll take a question from the back mic.
Okay. I understand this is peer-to-peer and very close communication, but for the passive tag reading-wise, I don't think there is any restriction for reading two devices at the same time for the passive tag. Is it true or it's not?
So currently, the Nexus S only supports reading one passive tag in the field at a time. There are a few technical limitations in place, and more than that, we think there's really just a user interaction limitation there, where, as we talked about, we think it's very important for the users to go directly to the application handling the tag they're interacting with for that instant gratification. So if the stack is handling two tags at once, if they both have NDEF payload, it's not clear what activity is going to be launched.
Right,
and
right.
so, we really think that, the best part of NFC is that it's just kind of, it instantly happens for the user. And so for that reason, right now, we only support one
So who's
one tag in the
handling
field.
those sequence basically?
Who's handling that sequence?
Yeah, if you have a passive tag and then both reaches at the same time, then who's...
Yeah, so if you have two passive tags in the field, it's going to arbitrarily pick one to be the first tag. And I think that depends on the ID of the tag, and the way it works is a polling loop. So the radio in the phone will look to see what exists in the field, and I think that kind of depends on which tag ends up responding first in the field. So it's pretty arbitrary.
Okay, thanks.
Yep.
Maybe to a question from Google moderator. Is Google going to partner with somebody to bring real-world NFC use, e.g. mobile payments? Well, for mobile payments, nothing to announce. I think we're looking at peer-to-peer, and we're looking at bringing zero-click sharing to the, to ice cream sandwich, and these are what we see as the use cases today.
Okay. Question from the first mic?
Is there a type of NFC tag that allows an administrator only to write to it?
Yeah, so there are different levels of encryption, authentication support in the tags that we talked about. Some of the tags support doing authentication using a shared key, and they have different access control rights in them. So the tags that you have actually do support that, and they're using the default keys. So what you can do is you can authenticate with the tag using a shared key, and that might give you, based on the access control rights, to modify the tag. Where if you don't have that administrator key, you would only have rights to read from the tag.
And that's type 1 that does that?
Type 4, I know, does that. It depends on the product specifically. So the MyFair DeskFire definitely supports that. Type 1 and 2, I don't believe, do that. Type 1 and 2 are simpler tags. They have smaller data storage. They're also a lot cheaper as well. But Type 4, if you get the MyFair DeskFire, will definitely do that. I'm not, off the top of my head, I'm not familiar with the exact capabilities of other products.
Thank you.
Hi, in your examples, you had one phone running an application and the other phone was on the home screen, so it was pretty obvious when you did peer-to-peer which way that data transmission was going to happen. What happens if there's an app running on both, and both are active and want to share data?
We're still debating what to do there, actually. It's a really good question.
Yeah, so right now, if you have foreground dispatch enabled in your application, everything will come to you. So our advice would be, if you really care about this in your application, you can set up your NDEF push. You can also enable foreground dispatch, and that means that while you're in the foreground, trying to do other things over NFC, you'll get messages coming. All the messages inbound, even if they're not destined for your application, and you can either drop them on the floor if you want, or you can indicate to the user that hey, I got something from the other side that's not mine. You might want to do something about that.
So if there's two separate apps, or if there's the same app running, let's say, on both phones, can they exchange information both ways during that one connection?
Yeah, the data will go both directions, and it will get dispatched on the other side depending on the dispatch stuff we talked about earlier.
Right.
So if you're going to go with the NDEF push, we suggest also going with the foreground dispatch, and then you have control over the inbound stuff while you're expecting to do NFC transactions with another phone.
Okay, to Google Moderator, can I add an adapter to my cell phone to support NFC? And the answer is yes, we just showed it. But we had to hack up the kernel, so.
Yeah, it was a bit of a hack, so there aren't any existing adapters today. Maybe someone will build one with the Android hardware developer kit announced earlier today, hopefully. What you can do is you can get stickers that are designed to be put on the backs of phones. And there's special stickers that have like a ferrite shielding on them because the stickers have antennas in them and they're pretty sensitive to the other radios in the phone. So if you're really interested in doing interactions with phones, you could put a sticker on the back. I mean, obviously you can't update the content of the sticker from non-NFC phones, but you could do something like put in Bluetooth addresses of the phone on that sticker on the back of it. A question from the first mic?
How durable are the tags themselves? Would they be wearable and washable?
I think you should keep that tag on for a few days and we'll
Yeah,
find
we'll
out.
do a little experiment.
Say if I wanted to put one on my back pocket and be slapped by a phone, would that be a good use case?
Yeah.
If you want to. I think it really depends on the tag itself. I mean, there are tons of different vendors building these tags. There are lots of, basically the tags are, a little IC on here as well with an antenna, and then that's all kind of packaged together. And there are lots of different people doing different types of packaging. So right now, you can get stickers. You can get, stickers like I talked about with the ferrite shielding on them, specifically for cell phones. There are people doing, things that you can put on CD cases to do, renting movies, that kind of stuff.
I'm sure I've heard about washables. I think some people are working on washable NFC tags that you can embed in clothing, similar to the RFID inventory tracking tags. I think we'll see those come soon.
Yeah.
Thanks.
Question from the back.
Yeah, suppose a user is writing to one of the tags that you provided and the payload is nearing the limit, the 2 kilobytes or whatever. Given the amount of bandwidth available, it could take several seconds to do that write. Is there anything in the API to ensure the integrity of that data, or do you have to kind of roll that yourself? Or could I just end up with a...
What you can do is, the code snippet we have is pretty simple. When you get the reference to the tag in the field, you can query it to see what its capacity is. So what you can do is you can check to see, is your data payload larger than the capacity of the tag, and you can check that up front. Beyond that, when you get, basically, if the tag, say, leaves the field while you're in the middle of doing that operation, you would get like an I/O exception thrown to your application. Okay. What exactly the state of the tag is at that point, I'm not sure. It probably depends on the specific tag technology that you're writing to.
Okay, question from Google Moderator. Will developers be getting access to the secure element?
So this one kind of goes almost hand in hand with card emulation. Typically, the hardware is set up to do card emulation through the secure element. Right now, we don't have any APIs to talk to the secure element, and we think that we probably won't be getting APIs to do that anytime in the near future in the SDK. There are a bunch of different reasons. Again, the secure element is a very limited resource. It can't hold a large amount of data in there. And if we open it up to any third-party application, there's going to be a huge resource contention over the secure element. Additionally, to talk to the secure elements, even from applications on the phone, you need to authenticate yourself properly. And if you improperly authenticate yourself a certain number of times, there are secure elements out there that will physically destroy themselves and can never be recovered. So that's something that we really think would be a bad experience for users, and we don't want developers getting blamed for breaking hardware. And it would be tough to know which application did it, and we think it would be a very bad situation. So today, we don't have APIs for that, and there are some constraints that make it tough to create APIs in the SDK for any third-party application to talk to the secure element.
Question from the front.
So I know you said that card emulation isn't going to be supported anytime soon, and that it's because of all the legacy reasons. But are there any vendors out there today that are building payment solutions that are based on peer-to-peer or NDEF, so that we can actually take our phones to local Starbucks and pay for coffee, using Nexus S?
I really hope so. I'd love to see peer-to-peer used for payment technology, used for payment. I think NDEF and peer-to-peer are the way to go going forwards.
But are you aware of anything that's already in the works?
No.
No. Okay. And the second question is, and this may be maybe irrelevant, but I know that it's only on while the screen is on. But what are the power requirements as far as, or what are the battery effects of having the NFC enabled?
It's about 5 milliamps in polling mode with the screen on, so it's pretty negligible compared to the backlight.
Okay. Thanks.
Question from the back mic?
I'm just curious, what's the smallest footprint size of the NFC stickers or tags that you've seen? I mean, is that pretty much like the technology requires it to be that big?
The smallest I've seen is 30 millimeter round, which is actually pretty small if you look at it. I think the bigger the antenna is, the better, the longer range you're going to be able to interact with it.
I see.
But I have seen 30 millimeter round, which is actually pretty small.
Yeah, it's 13.56 megahertz is used for all NFC technologies, so you've got some fundamental constraints on the antenna size, especially when you're powering a passive target.
Thank you.
Okay, going to Google Moderator. Does the Google NFC team see value in the intersection of NFC and identity? If so, what in the present set of APIs is useful for NFC-based identity? I mean, I think we see value for NFC all over the place, and not only specifically in identity, but for so many different use cases. And we're not going to be able to explore all of those. We're trying to put together the APIs for developers to try and build apps themselves. And I guess specifically the APIs available presently, well, there's the low-level APIs for transceiving to any tag. So there are some tags that have secure storage on the tag. You can use a low-level APIs to actually interact with those. Or all the APIs we presented to you today around NDEF.
Question from the front mic?
Actually, there are the 4 record type definitions in standard, but you didn't mention about the generic control. So when are you going to support that?
We don't have support for today. We don't actually have plans for supporting that right now in the dispatching mechanism. Mm-hmm. So if you're building an application, you can get the technology level and you can look at that, and you could interact with at the technology level and get the NDEF off the tag.
So could the vendor define their own, generic, the control for their own sake?
So for the you could define that. It just wouldn't get dispatched using the NDEF discovered intent. And part of the reason there is that the specification there doesn't fit very well into the Android intent system. So there's not a great way to map that into intents and allow applications to filter properly.
So I think we'll just take one more question, then we're out of time, but we're available in the office hours afterwards and hopefully tomorrow. So one more from the back.
Okay, I just wanted to ask about the critical mass issues. So basically, you're talking about hardware here. This is not like a QR code where anyone can print one out on a home machine, right? So A, can I just go down to a store and buy a roll of NFC stickers? B, there's going to be a period of time in which people get frustrated when they try to hold two phones together and nothing happens because the NFC support is not implemented yet in 100% of the apps. So how do you get from here to critical mass? I mean, will there be a symbol on the screen of apps, like a standard symbol that says, I support NFC? I mean, how do you get to critical mass? And overcome the hardware issues, especially, because these things, you can't just make them out of thin air.
Yeah. So for the first question, if you look on the internet, you can't just go to like a Best Buy or Fry's or something and just pick up a roll of stickers today. There are vendors on the internet that will sell them to you. They're not super easy to come by today. We're hoping that will change as NFC gets deployed in more phones and more consumers are starting to interact with the technology. Additionally, for the second question, I think we've added it to the Nexus S, and we're really hoping that people find value in the technology and developers start adding support for it to their applications, and then more OEMs will add NFC support to their hardware. In terms of identifying which applications have NFC support in there, we've been toying around with some ways to try to expose that information to the user, but we don't really have anything specific to announce today.
Yeah, I think it's a chicken and the egg problem, and I guess we're the chicken.
Yeah. All right. Well, we're out of time now, so thank you everyone for coming. We appreciate it. And we'll be in office hours if you have more questions.
Thanks a lot.